Hi everybody, just a quick introduction. My name's Gaz Roberts. For the past few years I've been into doing model rocketry and I was basically wanting to do a series of videos just to help people learn. I just want to start by saying I'm not doing this video for the views, I'm not doing it for the records, and I'm definitely not doing it because it's easy. I'm doing it because I really enjoy the challenge, and if I'm really honest, it really helps me manage with my ADHD. Engineering gives me something proper to focus on, to solve a problem, anything really, just to really get my mind stuck into it. And rockets, I don't know, I just like technology. It lets me use all my different skill sets, and it's one of the hardest, most rewarding things that I've attempted to do, really. But I get a lot back from it, and to make things trickier, because I don't like doing things the easy way, it's all going to be done out of carbon fibre. Now, there's not that many people out there that can make their own nose cones, tubes and so on, so we're going to give it a go. But along the way, we're going to have to make our own tools, we're going to have to make our own jigs, we're going to have to make our own moulds. So it's going to be a massive learning process, which I'm extremely looking forward to doing. So we're going to start small with the smallest motors. I'm going to be aiming to try and beat 4 British altitude records, one for each of the smallest motors classes out there. So we're not going to be using brute force and ignorant. There's no massive motors here. It's just going to be well thought out designs, some proper home DIY engineering, and trying to get the absolute most potential out of what we're doing. Now, with rockets, if you get it wrong, you know about it. So we're going for as much efficiency and precision and doing things as properly as possible. So it's not going to be just about me this journey, I'm hoping. By the end of the journey, I want to have learned as much as possible, and I want to be able to pass on that knowledge to others and hopefully get the next generation of young engineers involved in STEM, which is your science, your technology, your engineering and mathematics. So I'm going to show every single step, what works, what doesn't, and all the mistakes, which I'm sure there's going to be plenty on. As long as we've got all our fingers and toes at the end of it, our class had a success. So if you want to have a go at yourself, build your own rockets, do a bit of proper engineering with a real project to aim for, push yourself that little bit further, there's going to be a full series out. This project's not going to be just about one rocket. It's going to be about building experience, developing different technologies, bringing everything together, hopefully developing off comments, build a community, get everybody involved, and maybe at some stage go for something special where we could do a collaboration with a few different people building. The Black Knight project is what I've called it. It's not, it's just about learning, it's about improving, it's about taking little steps, step by steps. I could have gone down the route, which a lot of people do, which 99.9% of people do, and you can go and buy kits, you can take shortcuts. I could keep things simple, but I don't get the stimulation, the learning, and I don't think my full potential doing it that way. I love the engineering works where every decision matters. You've got to pick your materials, you've got to have the correct shaped nose cones, correct weight, balance, centre of gravity, centre of mass, acceleration, aerodynamics. The list is endless. And when you get something wrong with rockets, you get something wrong and you know it. It's either a cat or it's going through the air. You've got to be careful, and that's the challenge that keeps me really interested and motivated as best I can do. For someone that struggles with ADHD, which I could have a million hobbies in a year, but this year, 2026, I'm going to be really trying to stick to this and get the full potential out of it, and using as many home DIY tools that you can start with. Every design we're going to be trying to get to as close dimensions, positions from day one. Before anything flies, we're going to make sure that everything's fully simulated. We're going to check stability, drag, expected altitudes, rail speed, exits, required delay times, the G-forces that are put onto the actual rocket itself. All this can be simulated with basically free software these days, and a lot more, so you can check all that your hardware is correct, simulations before you go out into the field and ultimately lose a rocket. We're going to be using a lot of 3D printing, which is brilliant for prototyping. We'll be cutting bulkheads, fins out of flat sheets, so that can be done with a laser cutter. It can be done with CNC machines. Now, this is all cheap home-based stuff, couple of £100 equipment, sometimes less, but it gives you precision, it gives you repeatable results, it helps with testing, and every tool has its own place in the workshop, and knowing how to use them and what to use them for is half the job. So I'm hoping I can pass on a bit of experience. Lots of people think that you need to build, if you're using different motors, you've got to use different rockets. But what we're going to try and do on this project is work from one core design, an 18mm motor. There's ways we can change it. We can have slightly weighted nose cones. We can play lengths with balances, small deliberate changes by just adjusting like the length of the rocket by 10mm, or just tiny bits of weight in the nose, literally dialing in, balancing these rockets. And that's the way that we can get the changes through simulation, through testing, and then we can compare results, and that's the way we're going to move forward. It's not guesswork. We're going to do controlled development through testing, through failure, through simulation, and that's how you actually learn what makes a rocket fly, what makes a rocket fly higher. And when you're chasing altitude records, things change even more. We're going to have a minimum diameter rocket to cut down the drag, which means tight as to the motor as possible. We're going to look at the shape of the nose cones so we can cut through the air as cleanly as possible. We're going to use obviously carbon fibre so we can have extremely thin, small, light fins. We're going to try and taper them for aerodynamics. We're going to try and not paint the rockets, use filler or anything unnecessary. We're going to try and get the stability balance so we're on the edge of being a stable, understable rocket to stable rocket, so we can get the maximum performance. Because one thing that you do have with small light rockets is something called weathercocking, which if those rockets are overstable, the center of mass and the center of pressure are too far apart, it can develop weathercocking, which is where the wind can take control more of the rocket's dynamics, and you end up with a rocket going sideways chasing into the wind. So we're just going to get just the stability right to keep it flying straight. Altitude rockets are more about, like I said, precision, decision making, not brute force. One of the main things is as well on the smaller rockets is how and bigger rockets, but it's how they leave the ground can make a huge difference. The first meter of the whole flight is where it starts, and how your flight is going to continue to fly. They will self-correct, they will do, but if you come off a rail, a rod or a launch tower the wrong way, it's going to be catastrophic and potentially dangerous. So what we're going to do with this, we're going to attempt something a bit trickier, but we're going to build a launch tower. Now most rockets use launch slugs, which is basically a straw glued onto the side of your rocket. You put it onto a rod and up it goes. But launch slugs are very simple, how most rockets come with, but they disrupt the airflow massively, create drag, create cocking. Launch buttons is what you use on more of a high powered rocket. Again, it slots into extrusion rail. You've got to get them exactly right, and again, they can cause drag, but they're significantly stronger. So we're going to try and build a tower that utilizes no lugs, no buttons, just a clean airframe. So we get perfect alignment from the movement it moves. It's not the easiest option, but from what I've had a read, from what I'm so on, and just simple physics, it's got to be the right way to go. And let's be honest, it's going to look sick as hell, like a railgun from the first Quake. It's going to take more effort, it's going to take more planning, it's going to take more care, but this is why we're here. So there'll be an additional video step by step on how to do this. We'll be going through the mold making. We're going to get everything as efficient, the same, all for testing better performance where it really matters. None of this is going to be by accident, hopefully. We're going to design, we're going to simulate, and we're going to be manufacturing everything ourselves. I want you to join on, learn together. Now, with modern technology these days, a lot of engineering starts on the screen, i.e. CAD software, Open Rocket for rocket simulation. The results these days are very real, and everybody thinks learning CAD or some kind of different software can be daunting, whatever age you're at. But the results can be unreal. They can be so accurate and so close to testing. So we're going to be aiming for targets. Now, records are not just numbers. There's something to aim for. There's something that's what you can make possible when you slow down, calculate, and do things properly. We're not chasing records for tomorrow. We're going to try and build knowledge to learn and get them later, and keep getting them later, and build our way up. This project is here to help me focus. It gives me energy, a positive place to go when I'm struggling. The rockets and building and engineering is my happy place, and I want to share that with as many people as possible. So if you're into engineering, it doesn't have to be necessarily rocketry, whether you like fixing cars, building drones, woodworking, feel free to join us. You're going to learn new techniques, new materials to work with. Stick around, follow the journey, and just remember, this is only the start. This is the Black Knight project for 2026. There's a lot more to come, lots and lots of videos. Every step's going to be covered, from using 3D printers, making molds, laser cutting, using cheap CNCs, running simulations, understanding stability and performance, and then hopefully we'll take this journey all the way through to higher powered rockets, advanced builds, ultimate level 3 certification, and you never know, even a space shot one day. Nothing skipped, nothing hidden. If you've enjoyed this video, please like and share. We're here to learn. All feedback's welcome. I'm not easily offended, and I'm obviously new. There is far more people experienced out here, so all feedback is welcome. Enjoy your time. Thank you.